Hello everyone, happy to see you here. Welcome back to my channel. Today we have a great and relaxing algebra question. We know that the sum a plus b equal to 10 and the product a times b equal to 14. We need to solve this question for a and b. So if you have your assumption, your solution, you can also write it in the comments below and then we will check your answer. So it will be really interesting. Okay, so how do we solve this question? First of all, let's express from the first equation. So this is our first step. So from the first equation, we're gonna express this b. So b equal to 10 minus a. Okay, and right now let's plug in this b right here in the second equation. So instead of this b, we will write 10 minus a because we have an equal sign, so we can easily choose what options do we prefer. I prefer this expression because then we will have equation with one and only one variable. So from second equation, from equation 2, we have the next expression. We have a times 10 minus a from the first equation, yeah? 10 minus a, sorry, equal to 14. And right now we have only one variable. We don't have b, we have only one variable, and it looks like this is a quadratic equation. Okay, so right now let's solve it. First of all, we have 10a, yeah, we have 10a minus a times a, we have a square, and equal to 14. And right now, yeah, this is a quadratic equation, but we prefer a little bit different order because, yeah, we prefer squares on the first position. So let's change this order. So we have minus a square on the first position from here, plus 10a and minus 14 and minus 14 from the right side equal to 0. And right now the final tricky move, I'm not sure that you prefer this one or not, but I prefer to multiply this equation by minus 1 because I don't like this negative sign in the beginning. So this is, I like to do this a lot because then we have a classic order of signs. So a square, right here we change this sign as well, minus 10a and plus 14 and equal to 0. We have a basic quadratic equation at this point, okay? Right now let's solve it with the basic method of coefficients. Of course, this is up to you, but I prefer a basic method. Maybe a lot of students here, so let's practice it. A equal to 1, b equal to minus 10, so the second coefficient, and the third one, c equal to 14. And right now let's plug in each of these coefficients into this spot. So our all-known formula, our all-known discriminant, so b squared minus 4ac equal to b squared minus 10 squared. So this is our b squared minus 4 times a times 1 times c times 14. And as a result, we have 100 minus 10 squared minus 4 times 14 equal to 56. Yeah, we have 56, and our square root, our discriminant is positive. This is a great sign for us because right here we can easily say, okay, we have two real number root. It looks like that. Let's solve it. Right now, let's remember a classic formula, our a first and a second. Yeah, we need to find it for a first and a second. So a first and a second equal to minus b plus minus square root of discriminant and all over 2a. As a result, let's plug in everything. We know minus b, so minus b equal to minus 10, this b, plus minus square root of discriminant, square root of 44, and all over 2 times 1. We know everything. Right now, these two negative signs is a positive because we have two negative signs, minus times minus equal to plus. So we have 10 plus minus square root of 44. This is not a table case, but we can express this as 4 times 11. This is the best way. How can we express this 44? All over 2. Right now, I really hope you understand, I really hope you remember that property, so we can split it. We can write it as square root of 4 times square root of 11. So we have 10 plus minus square root of 4 times square root of 11 and all over 2. Why do we split it? Because right now we can find square root of 4. We can estimate this square root of 4. So 10 plus minus square root of 4, we can simplify it. We can write it as 2 square root of 11 and all over 2. And right now, the final tricky move, we're gonna factor this 2 from here because I want to cancel this 2 from numerator by this 2. So we can write 2, and in parentheses we have 5 plus minus square root of 11 and all over 2. We're gonna cancel this 2, and our final answer 5 plus minus square root of 11. Really great. And right now let's find our second pair, because not like pair but the second answer, because this is our a first and a second. Let's write it. So this is our a first. Let's write it with the positive sign. So we have 5 plus square root of 11, and of course our a second equal to 5 minus square root of 11. So these are a first and a second, but don't forget about the beginning, because in the beginning we had not like a substitution, we expressed b through a. So we have b equal to 10 minus a. And right now let's remember that expression. Yeah, so we have b equal to 10 minus a. So we write but b equal to 10 minus a. So as a result, we have at this place we can find real quick our b first. So b first equal to 10 minus a first. So 10 minus a first. And as a result, we have b first equal to 10 minus 5 plus square root of 11. Square root of 11. And as a result, our b first equal to 10 minus 5 minus square root of 11. So from here, b first equal to 5 minus square root of 11, and this is our second answer, second solution to this question. So as a result, we have one pair, 5 plus square root of 11 and 5 minus square root of 11. Right now the second pair, but to be honest, we have absolutely symmetrical answers. So right here we will write the same thing, and we will have 5 plus square root of 11. So just let's check it. So we have 10 minus a second. So right here we have b second equal to 10 minus a second, 5 minus square root of 11. So b second equal to 10 minus 5 plus square root of 11. And from here, this is equal to 5. So b second equal to 5 plus square root of 11. So we have our answer. Let's group all of this together and let's write it as a final answer, and then we will check it real quick. Okay, so we have our answer. We have two pairs, first pair a first and b first. So a first, 5 plus square root of 11 from here, yeah? So we have 5 plus square root of 11, and the second one, 5 minus square root of 11, yeah? And the second pair, 5 minus square root of 11, this is our a second, 5 minus square root of 11, and 5 plus square root of 11. Really great, this is our answer, and in the end, let's check real quick our answer. So let's write our question from the beginning. So a plus b equal to 10, and ab equal to 14. Yeah, right now let's check real quick, for example, our addition, and we don't need to check both of these pairs. Let's check, for example, our addition by this expression or by this one. Doesn't matter, because we have a symmetrical thing, and moreover the main thing, because a plus b is the same as b plus a. Okay, so we don't need to check both of these. Let's check, for example, a plus b equal to 10 by this expression, by this pair. So 5 plus square root of 11 and plus b plus 5 minus square root of 11 equal to 10. Really great, because we cancel it and we have 5 plus 5 equal to 10. So addition works absolutely perfectly. And right now let's check our multiplication. So we have 5 plus square, and the same thing with multiplication. We don't need to check both of these, because a times b equal to b times a. So we can easily check. For example, let's keep this answer. So 5 plus square root of 11 and 5 minus square root of 11 equal to 14. And right now let's look at this question from a different perspective, because a lot of students might be multiplying parentheses by parentheses, but just remember your school formula. Let's write it, for example, right here. So x squared minus y squared, school formula, x minus y or x plus y, let's start with it, and x minus y. And if you look closely, we have 5 plus square root of 11 and 5 minus square root of 11, okay? So we have sum and we have a difference. So this is exactly our case. So this is a difference of squares. This is our a and this is our b. And difference of squares, let's write this formula. 5 squared minus square root of 11 squared equal to 25 minus square root of 11 to the second power equal to 11. Yeah, square root of 11, so we're going to cancel these two, this square root, and we have 25 minus 11 equal to 14. Yeah, and this is our answer, absolutely the same as we had in our question. So we have a product works perfectly, and addition works absolutely perfectly as well. Yeah, and this is my solution to this question. I really hope you enjoyed. I really hope you understand it. This is a classic, a basic basic algebra question. This is a quadratic equation, to be honest, a quadratic equation with the different things. So we just express b from here, and we have absolutely great solution, absolutely classic solution. This is a basic quadratic equation, so we can easily say that this is not the hard question, and I really hope you enjoy it, and I really hope you understand it. But if you still have any question, write a question in the comments below. It will be really interesting to read about it. Let's exchange information, let's write you different thoughts, because a lot of people, a lot of opinions, a lot of discussion. And of course, if you have your answer, your faster answer, write your solution in the comments below. My main goal is to try to make math clear and understandable for, first of all, for students, because maybe a lot of students here, and I just want to solve this question step by step in classic school method. I don't want to jump, I don't want to like forget about the different parts. This is a classic solution to this question, and I really hope that students will understand it. And I want to say thank you for watching, for being here. And of course, if this video is helpful in any way, don't forget to leave a like, to write a comment. What do you think about this type of question? It's extremely important to see you respond. Thank you for your time, have a great day, take care of yourself, and see you in the next videos.